Now let us understand what's meant by a regular definition. See, there can be several regular expressions when we define a language. A series of expressions will have to be used, and one regular expression might be used by the other regular expression. So it will be very useful if a regular expression can be given a name. Once a RE or a regular expression is named, it can be reused subsequently. Now, to give name for a regular expression, we make use of regular definitions. Now, in the regular definition, there is a right hand side and left hand side. Right hand side of every regular definition will be a valid regular expression. And in the left hand side, we have a symbol which acts as the entire name for the entire regular expression. Now let us see the notations for a regular expression. See, here we can see that we have some basic set of alphabets, and it is represented by this symbol sigma. Now a regular definition is a series of characters. As I told earlier, we have a right hand side and a LHS left hand side. You can see that all these R1, R2, Rn parts, these are our regular expressions. All Ri's, R1 to Rn, are regular expressions. Now, whatever we see here, these are symbols that are essentially names for each of these regular expressions, D1, D2, etc., Dn. Now, the thing is that D1 is not a member of our original language, sigma. And all these Di's should be distinct. We are naming each regular expression, and since each of these names are to be distinct. Now, what is the composition for each regular expression? Each of these regular expressions will be over an alphabet, over the given alphabet of the language, union these D1, D2 till Dn. Why D1 also belongs to the set of alphabets for Re's? This very well you can guess, because since D1, all these D1s are names for earlier regular expressions, we provide these names so that, suppose that R1, this is a big regular expression and this is named as D1. Suppose that we want to make use of D1, say in Dn. So this D1 will be part of Rn. That's what meant by the second statement. Now, since we are restricting Ri to this set, alphabet of the language union D1, D2, D3 and D-1, we cannot have a recursive definition in when we go for regular definitions. Recursive definitions are not allowed. Now, let us see one example of such a regular definition. Here we know about an identifier in C. It is a combination of letters, digits and underscores. The first symbol in a identifier should be a letter. It can be either uppercase or lowercase, and it can be followed by either a letter or a digit. If we want to add readability to our, say, a long identifier name, we can have underscores in between. but the rule is that no successive underscores are allowed. Now, with these rules spelled clearly in the natural language, we are in a position to judge if an identifier is given to us and if we are asked to say which of these are valid identifiers as per the C syntax, we will be able to classify that manually. The same pattern can be formed as a series of regular expressions. You can see that here we have three regular definitions that corresponds to this identifier. Here we can see that the third one actually represents a full identifier, and all these other forms are created using the identifiers of other portions. So let us start the letter, how to form a letter. Letter underscore is a name given for this regular definition, regular expression. It is a combination of uppercase alphabets and lowercase alphabets. Remember about the or we have put here. Or operation says that it can be any of these letters. A or B, see uppercase letters, it can even be lowercase letters. And their use of uh, underscores is also allowed. So we have added one underscore here. A or B, C, etc. underscore, letter underscore. Now, to represent digits, we have one more regular definition. Right hand side of this definition is again a regular expression. It indicates the presence of digits. All possible combination of digits are given. All digits are given here. Now using these letter, underscore and digit, we can form the regular definition for an identifier. You can see that ID is a name given for that, and ID is a combination of earlier definitions. We make use of definitions here. Since we had given names for all these regular expressions, we can conveniently make use of these names given to them to make our final regular definition for the identifier. Letter followed by zero or more combinations of again a letter followed by letter and an underscore. It can be a digit also. So this makes sure that whatever identifiers are formed, it will be as per these given rules. This is a regular definition for as identifier in C. Let's take one more example. Here we have floating point numbers. Floating point numbers and integers. How a number can be represented as a regular expression. That is our concern now. We have few examples here. We can see how they look like. First one is an integer. We can see that there all digits will come and it should not start with 0. Second is a floating point number with a decimal point and fractional part. The third example, we have only fractional parts. There is no whole number. And you can see that these two are expressed in a different way. This is also a floating point number, but in this case we have presence of e. Mantissa and exponent appears here, and here the after e it is a positive number. We can see that after e here a negative number comes. Now these examples are provided to sum up the rules that we had learned in our C programming days about how an integer and floating point numbers can be formed. We need not repeat them here. These examples are enough. Now, how can we frame the regular expressions and ultimately the final regular definition for an unsigned number, which will encompass an integer and floating point? So the first one, we have we have a combination of digits. So each digit will be all numerals from 0 to 9. It is represented as a digit. Now, how a digit can look like? A digit will be one digit followed by 0 or more occurrences of further digits. So that is also put as. This part indicates we can know that this is very well an integer part. Now we would like to add this fractional part. So the first thing to note is one, these two examples. Here in the fractional part only, again numerals will appear. So here see how this RE is formed. This can be anything. We can be convenient names, but this right hand side should be perfect. Dot represents the decimal point. After dot, we have digits. There are digits 1, 2, 3, 4, 9, 0, 8. All these are digits. Here also, we have a digit. 6, 7 is a digit. 5, 6 again digits immediately after the decimal point. So after the decimal point, we have these. What's the digits? Digits is again is a regular definition for this regular expression. Digit star, and digit ultimately it is numerals from 0 to 9. Either digits or epsilon, because here 1, 2, 3, 4. A fractional number is, it need not appear every time. We make a regular definition for both an integer and a floating point. So this can be even epsilon. Now this is optional. Now we have this exponent part. How the exponent part can be given? Exponent part will appear again after the decimal point. Now after decimal point, you can have an E. First, let us have a glance here. After E, what are allowed? After E, it can be signed. First of all, a sign can appear. Then a digit will appear again here. So here it is E. Then we have specified it can be plus, minus, or epsilon again. Because if plus is not specified, it is taken as positive. Hence, epsilon comes here. After that, this can be a series of digits. Digits is put here. Or, as before, this is optional. Without an exponent part also, we can form a fractional number. We can have this E. Now let us see how this is formed now. See the number. Number is a combination of all these 4 RDs. Initially digits. This is followed by the optional fraction and optional exponent. This is how an RE is formed. Several REs are formed and they are properly named so that we can arrive at the complete picture. Now let us take the one more example of this. Let's take this example. Suppose that we have a phone number like this, what can be done. Now this phone number, as you see, it is having these components. This is the area code, which is enclosed in a pair of braces. We can see a hyphen here. Hyphen followed by hyphen exchange code is provided. After exchange code, we have the actual phone number. Area code, we have 3 digits. In the exchange part, we have again 3 digits. In the actual phone number part, we have 4 digits. This is the arrangement. Now this example and this rules gives us enough arms to frame the regular expressions and regular definitions. See, as you can see here, all these are all a combination of digits. This number matters, and presence of braces parenthesis is also, it should be taken care. So first of all, we will try to form digits as such. So we have digits here 0 to 9. It can be any valid code. Now we have another code here. See the area part. Area part is to be specified. We can see that the area part starts with a parenthesis, a pair of parentheses. After that, we have digit and we quantify it with 3. There can be 3 of these, 3 digits. Again, we have the exchange code. Exchange code is nothing but, again, is a group of 3 digits. It is specified here. We have phone number. Phone number is a group of, again, say 4 digits. And all these 3 RDs are used here to form the actual phone number at the end. So this is how a regular definition is useful in creating complete expressions for a cause. It can be an identifier, it can be a telephone number, anything for which a pattern should be created.